My name is Bob Holland. This is our Inventor webinar series. We're going to be going over the new features for Inventor 2016 and the new features that were introduced in Release 2 and Release 3. I'm part of the Inventor tech support team, and the people that will also be presenting will be Charlie Mercer, Don Werner, and Nathan Chandler. Okay, now we're going to cover AnyCAD, Shape Generator, ForceEffect, Electromechanical Workflow, Connected Design, IFC Publishing for building products, some enhancements to the step format, and drawing overlay. Some housekeeping. What we're going to do in the series is this is for providing a series of tips and tricks for a wide variety of users, whether or not you're new or you've been using it for a while. We have 5 scheduled so far. These are the dates. You don't have to worry about writing anything down. We're going to be broadcasting this. It's being recorded. So we're going to go ahead and we're going to make the slides available to everybody after the fact also. All right. If you would like to ask us any questions, please use the panel that is on the Go to Meeting, the questions area, and right above your question, you'll be able to get our answers. We will be providing about 10 or 15 minutes at the end for questions and answers. Some resources for tech support are our knowledge network, our product forums. We have a installation licensing blog, and all of the rest of our blogs that are available. These are the links to get R2 and R3. You don't have to worry about writing these down. We'll be providing them for you. All right, so right now we're going to go over AnyCAD, and these are the formats that you're probably used to seeing, but we've added some features. Now we have the ability to treat many of the files that you would get from other products like Pro-E or SolidWorks or CATIA. You can treat these files as you would like an X reference in AutoCAD. All right, so I'm going to review how we used to do it. When we would bring in, say, a step file, we were presented a full set of options, and one of the features that seemed to be overlooked and probably shouldn't have been is the repair environment. The reason why we want you to use the repair environment when you are bringing in like step and IGES data is if you introduce bad information into your model, it's just like adding a bad part onto your assembly out in the field. We don't want that to happen. So this can affect performance. And have you ever had an instance, say, where you go into a drawing view and the view just would never be precise? These are parts of the reasons that this can happen. Okay, so if you have these in and you didn't check them before, you have the ability to right mouse click on an imported body and you can say repair it. This will allow you to go in, you can find errors, you can heal errors. I've included a article that we have. It's video that will help guide you through checking and repairing imported data. Now, this was done for 2014, but it's still very applicable. We're also going to be creating a series of screencasts that will help guide you through fixing individual issues that you may find in this. This you want to make sure, particularly for library parts, that you're going to be using over and over. And you're basically accepting these as being partly yours. Okay, now for AnyCAD, when you're in an assembly, you can place from Content Center, iLogic components. We now have the ability to place an imported CAD file. The other is when we go in and we say new, we have the ability to just import. This will allow us to come in and if it's like a step file, we can convert it. So what this does is it's going to convert it right into our models. You'll see similar information that we used to ask. You'll notice that there's the ability to reference it or convert it. When you are in this initially, the default is convert. For reference, you're not asked nearly as many questions, and you also have the ability to select those parts or subassemblies that you actually want to bring in. You'll notice that this has pretty much the same behavior as the derive command. Okay. When you bring in a referenced model and somebody has made a change to an underlying part of, say, a referenced assembly, if it doesn't matter what the product was that created those files, when we reference them in, they change, the update button will highlight, and this will allow you to just click on the update, and that will update your underlying files. So it makes it pretty easy in a real-time mixed environment. Okay, remember, when you're bringing in particularly independent files like STEP, IGES, we don't prompt you to take it into the repair environment anymore. You'll need to do it yourselves. All you need to do is right mouse click on the imported body or there in the browser and select repair bodies. We got to remember to do this, and there's a link again to the video for how to repair. Okay, now we're going to go over shape generator. And for this, I'm going to pass this over to Charlie Mercer.
All right, thanks, Bob. Basically, we're going to look at the shape generator. It came out in R2. Basically, what it's used for is to kind of give you an optimized configuration of a part and do like a weight reduction of it so that you can give it a load, give it maybe want to reduce it by 50, 25, 75%, and you can actually do that now in Inventor and pass it to the actual model. All right, let's go to the next slide. And basically, this is for just a single part file. It's not for an assembly, so you'd just be doing this on a regular part. And I can't stress enough that it doesn't eliminate the need for a full analysis. So if you do this, yes, it's removed some material there, but I highly stress that you have to go back and do another structural analysis of it to make sure it still functions the way you want to. All right, let's go to the next slide. You can see it right here in the shape generator. It's right in the ribbon under the 3D model, and it says shape generator. And in the lower screen capture there, you'll see that if you've done a structural analysis or stress analysis in the past, a lot of this is going to look familiar. It's only going to be the last few icons there that you'll actually see the new shape generator options. Let's go to the next slide. So one of them is, I just wanted to point this out. I mentioned about doing a stress analysis or a static analysis. If we pick on create study, that's where the option is. If you pick one of the shape generator commands, it will automatically toggle to this. But I wanted to show this to you because if you come back and say, hey, I want to do an analysis of it, you're going to get the same dialog box. And in that case, if you were just to do the straight analysis of it, you would pick the upper option. So we're just going to look at the shape generator and see how that works, and we'll take it from there. Okay, next slide. Okay, in the ribbon itself, like I mentioned, there's 3 new areas: goals and criteria, which gives you preserve a region. So preserve a region would be for if you're mounting something, you want to make sure that there's enough material around, say, the bolt hole, so that you can keep some material there so that you don't actually crush your part trying to mount it. And then the second option is the shape generator settings themselves. And those are we're going to see those in a second. Then there's run shape generator, and basically that just starts off the analysis. And one that I think everyone's probably going to end up using is export or promote shape. What that one will do is, and we'll see it in the future, is it's going to actually bring it into the part model and kind of overlay on the part. And we'll see that in just a few seconds. So let's go to the next slide. All right, shape generator itself, we're looking at preserve a region. And like I mentioned, it's for excluding an area in the model. It could be surfaces. In this case, the dialog box shows a cylinder for like a hole. You have a box option also. And you can set some of those right there. This one, it shows it, and then I've also expanded the More button, as we'll see, so that if you want to change the center point of some of these exclusions, you can do that. All right, let's, next slide, please. The shape generator settings, not very many here. Again, we got a mass target, and it's we're going to look at reducing the weight by about 60%. So it gives you the original mass and then what you're shooting for. It doesn't have to be 60, it could be 50, 25, whatever. And then the mesh resolution. If you've done analysis before, you'll know that sometimes you have to refine the mesh or make it a little bit coarser depending on how detailed the model is. Usually the more detailed, the finer the mesh. You get a little bit different answer in some cases. All right, next slide. All right, this is a recorded one, so I'm just going to talk over it. So we're going to actually go through and use the shape generator itself. Oops, we're going to back up a little bit. And we're going to try that one again. Okay, so I'm picking on the shape generator command. In this case, we're actually going to go through there. You can see it where it says static analysis. We're going to pick it towards shape generator. We're going to go in and assign material. Like I said, if you've done an analysis before, this is all going to be very familiar to you. We're going to pick aluminum. Then you have your constraints, your fixed, your pin, and your frictionless ones. So I'm going to pick a pin one and pick those 2 locations. So I'm going to apply one there and apply one right there. And okay, again, we got force, pressure, bearing, moment, and gravity. So I'm just going to apply a force right on here. It's like a brake pedal for a car, a mini bike, or a motorcycle. So we're just going to apply that right there. And now we're going to get into preserving a region. And what do we want to do? We want to preserve the region around the mounting holes right there. So we pick on this one, and you notice right off it gave us one going in the other direction, so I changed it to 0. It centers it back up, and we want an excluded region of about a ½ inch. So we're going to do the same thing again here. We're going to come down and pick the other one, if we can pick it again, and then we're going to exclude another ½ inch, and you can see that in those green shaded areas right there. So when you're all set, you just cancel out of that, and then we can go to the shape generator settings. Again, do we want to do 50, but we're going to do 60, and then we're going to just pick on the shape generator, and we're going to run it, and through the magic of editing, here we are at the very end. So it gives us a rough idea about a 60%, so we can export that back to the regular file or STL file. And we went back to the regular model file, which gives you the opportunity to go back in with it there and then do some cutouts with it superimposed over the actual model so that you can get a kind of an idea. When I do finish that there with the cutouts and everything, I would really recommend going back and doing a full analysis to make sure that it still meets the physical criteria of being strong enough and bold enough to hold everything. So basically that's Shape Generator, and like I said, it's a part, and you can do your parts in there. We can see where we could overlay it, and gives you another opportunity to kind of lighten some loads, or it gives you a direction to move in. And I think what I'll do now is I'll turn it back over to Bob, and we can move on.
Thank you, Charlie. All right, now what we're going to do is go over ForceEffect. ForceEffect is a product that we've had for a while. It's browser-based, and you can do kinematic and static analysis, and we've now made this available through Inventor. And this will allow you to, say, sit out at a coffee shop and actually maybe a meeting, work up your design and do a quick model, take it back. When you get back to work, you can bring it into Inventor. All right, so what I'm going to do is show you a little bit. This one happens to be a well pumping. All right. Okay, so what we've got is we've started up ForceEffect and we've brought in an image, we've sketched out, make sure our kinematic study works. Now what we're going to do is we've saved it, we're going to bring it into Inventor. So we go and open up our study, and what we'll do is we'll show you a little bit of how this works. We're going to go ahead and make some changes to this. So what I've done is put a reference dimension so that when we go back and reopen it, then you can see the changes. So we start ForceEffect directly from Inventor. You'll notice it's a tab in Inventor. And what we're going to do is get rid of a grounding. We're going to lengthen the leg and go ahead and reground it. Then we're going to shorten that, and then we're going to come back, make sure our study still works, and then what we'll do is go back in, we'll save it, go back into Inventor, and tell it to update, and you'll notice that it comes right back in. This is, at this time, a more or less a one-way deal. You can't take it from Inventor into ForceEffect. It goes from ForceEffect into Inventor. So with that, that's a overview on how ForceEffect will work and bring that information into Inventor for you. All right, so now we're going to go over the electromechanical workflow. Now, the electrical mechanical workflow allows you to bring in IDF files, so you can, say, populate a cabinet. We also have a customizable component library. What we provide you is a library template, so you can create your own custom library and populate it with your IDF components. So when you bring in an IDF component, it's going to do a substitution. So if you have branded any of these components or done minor modifications to them, you can do a automatic substitution as you bring them in. And by doing this, it can speed up your integration into other analysis packages. All right, so we're going to go ahead and to start this. We're going to go ahead and open up and bring in an IDF file. We can select those parts of the assembly that we want, those components, and we can filter. We can filter based on size, holes, We can choose what outlines we want. Then when we bring it in, it's going to show you what it substituted into the from the library. And the filtering is showing you that it's filtered by size, so it's only showing you the larger components as opposed to all of the components. So, and it's the whole thing. And what this will allow you to do is you can bring in what you need so that you can get it into, say this is thermal analysis, or you can go in and do an airflow analysis. Okay, so that's with the thermomechanical workflow. So now what we're going to do is go over to design. Now, connected design will allow you to you create a model in Inventor. You can share it with the world in a very rapid fashion, and you invite who you want to see via email. This is done through Autodesk 360, and we create a new, it's called Design Share. And this allows you to create a very rapid 3D model. This way, if you you don't have to do like a 3D PDF and email it to a bunch of people. What this does is it's very dynamic, very fast. You can create an inventor, you can even manage it in Vault, and your design share, it doesn't affect anything that is in Vault, which is pretty handy. All right, so what we've got is we have model here. We're going to go in, select design share, and we're going to get the preview, make sure that we're getting what we want, and then after we've checked, make sure that that's what we want, then we'll go in, start sharing it to those folks that we want to share it with, and then you'll notice that it's going to go down. It takes a little while. This isn't the fastest model, but it takes less than a minute to do this model, get it up into the cloud so that you can immediately share. The email is automatically sent to those individuals that you've asked to send it to. They're going to get a link. When they click on the link, it's going to take them to the Autodesk A360 website. You are going to see the model. You get the welcome page, and then it's going to open up the model for you. And when you open up the model, it takes just a few seconds. It's going to build the lightweight model in here. It's going to allow you to do your zooms, your pans, rotates. You've also got a few other features in here that are pretty cool. So we can actually do a slice in here, and we can slice through it so you can actually see at different levels. You also have an automatic exploded view that you can just tell how far you want it exploded. You can put it there, zoom in, check out parts, and it's pretty cool. Now, the other is the important part. You can leave, or they can leave you comments. So you can prompt them for the information you want, and they can give you feedback on what specifically maybe you're looking for, what they would like to have changed. So this is pretty quick, lightweight, pretty handy. I've already explained this to a couple of folks. It's like, oh wow, this is cool. So we're already starting to get traction on that. Okay, now next thing we're going to go over is you don't see it by default. So when you start Inventor, you're going to see a little icon. When the icon's there, it's going to be a little blue icon in the lower right. If you don't see it, you go to the View tab, User Interface, and you turn it on. So it's the same place if your browser were to ever go up missing, same spot. Okay, so what we're going to do now is we've introduced a new file format for BIM. When you are exporting building components, you used to have RFA and ADSK. We now have a new format, and it's IFC. This is more of like a step file format for the building information modeling environment. So it's another option when you're exporting. All right, so from there, what we're going to do is I'm going to pass this over to Nathan Chandler so that he can go over our enhancements to the step file format.
Thanks, Bob. Yeah, I want to talk briefly about the new step enhancements that have been implemented in Inventor 2016. They're not quite as sexy as some of the stuff you've seen with the shape generator and the shared design tools, but they're really neat. You know, whenever I send step files to someone in previous versions of Inventor, I've always wondered which option should I select? Should I be selecting the 203 or 214 option? And the great news is in Inventor 2016, we've added a new format that's recently developed, and it's kind of a combination of the two previous ISO standards. So you can just select that one and feel confident that you have the right step format selected. You know, and some of the things that are kind of underlying this new format is that it has some great advantages where it has increased support for PLM interoperability, better support for PMI or geometric dimensioning and tolerancing, and it has support for mesh data. Now, in 2016, you're not going to see these advantages come to fruition, but you know, this is kind of setting the foundation for future efforts. So, if I could get the next slide there, Bob. Another enhancement we've made is the step zip format option, and you can see the revised step options dialog there on the right. There's a checkbox there, and if you select that checkbox, you are going to create a step Z file or a step zip format. What this does is it zips your step file, kind of treats it like a text file, and it reduces the overall size of your assembly. So if you've ever tried to send somebody a step file of a large assembly and maybe it's too big to get through email, of course this is not much of an issue these days with the file sharing programs, you know, like Autodesk 360 Drive, but you know, this is a great way to reduce maybe you know, the file size of your step files. And you can see from a little screenshot that I've put in there that even small assemblies like the sample scissors file, I've reduced that from 150 kilobytes all the way down to 32 kilobytes. So you know, in a number of cases, you'll find that you get significant reduction in file size there. So some other great things to note is that this is just using the standard zip technology. So if you send this zip file to somebody and they don't have Inventor to import it back into, they can just use their standard, you know, zip programs, WinZip or WinRAR or 7Z. Any one of those will unzip that file. Let's go to the next slide there. One thing I did want to note about the Step Z format is that because of the way we've changed the importing dialog box, you need to be mindful of your file location. Previously, you were able to set a default location in Inventor where you imported, it would automatically import files into a particular directory, but now there's a file location located at the bottom of your import dialog box. And if you're not paying attention and you import a step C file, it's going to unzip those step files into this directory. And what it'll do is overwrite any existing Inventor files that you have with the imported step format. So the result will be that you've replaced your existing Inventor data with a dumb solid step file. So all your feature history will be lost and iProperties and that sort of stuff. So just be careful. We've added some warnings in, but just a word of caution there. And with that, I'm going to go ahead and pass this over to Dawn, who is going to be covering the drawing overlay feature.
Oh, well, thank you, Nate. Bob, can you make me presenter? Or I can talk over this while we're getting that set up. Basically, the drawing overlay allows you to take a AutoCAD model and drive it in your Inventor environment. Bear with me a second here. Okay, so hopefully my screen is being showed right now. I'm going to flip back just to the AutoCAD portion. This is, by default, just lines and arcs. What has happened here also is in the AutoCAD environment, you have the opportunity to drive it via parameters. This is one way, is the AutoCAD model is changed. Here in this environment, the linking or the overlay in the Inventor environment will automatically update. So what I'm going to do is switch back to my Inventor. And the first thing you want to do is start a part file, and you would want to save it. Otherwise, if you do not save it, you will get a message saying it is prompting you to save the file. Even though it will allow you to import it, it would possibly give you some errors along the way. So again, just an advice to save the file. One of the things too here, when you go to the import command, which is located on the modeling tab, the 3D model tab, just to make sure that it's an AutoCAD file. This is more of a safety check. You can come down here and choose the AutoCAD format. You notice here I have a couple. I'm going to show you a couple of options here. We want to just start with just a straight overlay. And the first thing it wants you to do is pick a plane. So I'll go ahead and pick the XY plane. And the next thing it wants is a center point or a point to pick. Now, what you'd probably want to do is have this either visible prior, or you could pick anywhere on the screen. It's just a placement for the AutoCAD drawing. You will get this message that pops up. If you have tried this in the past in prior releases, we had a convoluted dialog box show up, and this has basically been taking its place. It's going to force the import. I'm going to go ahead and say OK. So the next thing here is what you're going to want to do is you're going to want to place a sketch on the actual plane. So it's kind of a two-step process. So I'm going to go ahead and pick a sketch. Now I could come in here to the browser and pick it here, or if you wanted to, you could actually come up and line it up. I'll just back out. Now that we're in the sketch, you will now notice there's a new project command, which is allow you to project the 2D geometry or the DWG geometry. So as I select that, you have some options up here where you can pick single geometry and you can pick all the connected ones, or if it was an AutoCAD block, for this one I'll leave it on the single pick, but I'll go ahead and I'll window and finish the sketch. Now some of the options here too with the overlay, if you come over the overlay, there is options to display layers. So in this case, I'm going to take off the top view, and you can see up here it will disappear. And at this point, now I can go ahead and create the geometry from here with, I'll just use a simple extrude. And what I'm going to do now is I'll switch back to the AutoCAD file and just make a simple change. So in this case, I'm in the AutoCAD file. I can actually bring up my properties, and bear with me, I'm not a fluent AutoCAD guy, but right now I'm just going to select on this parameter, and I can come into here and I can make a change to say 12 inches. Next thing you want to do is save the AutoCAD file. And when I switch back into Inventor, the update button should now be available to you. And as I update it, you can see the file stretch. Now in this, I'm just going to flip to another file I have in Inventor. Now for this particular one, it's basically the same model, but what I decided to do, I'll go ahead and I'll rotate it so you see a little bit more, is you notice here that I've actually overlaid, it's basically the same file, I just gave it a different name so I could show you. But for here, if I come into my layer visibility and turn both of these on, you could see that I've actually imported this twice. On this plane once, and on the back plane is another overlay. And what I have done is basically lined up the top view here with the side view over here. And by doing that, by bringing it twice, I'm able to go back to my overlay 2 file. I'll open this. It's the same model, but what I've done is I'm using both of these parameters. The parameters that are in this file here. If I wanted to stretch the thickness out, go ahead and I'll select that, and I'll make this say 4. I'll hit a return, and I'll back in. I'll make the cut here a little deeper. I'll make this 1.5. And if I wanted to, I could say come over here and I can make a stretch on this, and let's say 14. So as I'm making the modifications in AutoCAD, this geometry is going to go ahead and update the model. So on this one, you can see the update button, and you'll notice that this whole, let me put it in a better perspective, you can see it. The whole model will update and drive. So the process or the thought process behind this is that it will allow the staff that uses the AutoCAD files for some of the geometry to basically drive your Inventor model from AutoCAD. And that's basically all I had for this. I think we finished up a tad bit short. We had scheduled for a quarter of finish time. So I don't know if there's anything else that Bob or Nate or Charlie would want to add to this, but that's the whole new overlay.
Thank you, Don. So what we're going to do is we're going to open this up for questions, and if you have questions, go ahead and put your questions into the webinar, and we will go ahead and answer them. Dawn, Charlie, are we seeing any questions come in?
At this time, I don't see any, Bob. I don't see anybody who's typing.
Okay. All right. We'll give them a minute to see if they have any questions, and if they don't, we'll go ahead and wrap this up. Okay. Well, it looks like we're probably not seeing any more, so we'll go ahead and close this out. Thank you all very much. We will be posting this on the web. It'll be recorded.
I think we just had one question pop in.
Okay.
Bob.
All right.
Bear with me a second. I'm just looking at it. So the question, Bob, is: Are there any webinars? Are there other webinars of the same content?
No.
So if the question is, I think the question might be based around: are there going to be any more R2 or R3 webinars?
No, the next one is going to be in regards to configuring Inventor. and then we're going to do a series of guided level of instructions. So the one after that will be like a beginning level 1, how to create parts, and this will progress throughout the whole series. So we will be sending out an updated list of content, and we will be changing these every 6 weeks. So the next one is going to be configuring Inventor. All right, do we have any other questions that have come in?
Yeah, it looks like we have a couple more coming in here.
Okay.
So there's one for CNC programming help. I'll address that one via text, but then there's a couple more. Is the shape generator data displayed in the model tree, and can it be suppressed or deleted after modifications to the model have been made?
Charlie, did you want to address that?
There is an icon in the browser, but basically it's just an overlay. Anything that you want to do, you have to actually go back into the shape generator part of its product itself.
So the shape generator creates a mesh object and that allow you to build over and through it. Okay, let's see, we have another one on how to make product configurator with iLogic. Effort to provide an A360 localized version. Better connect functionality initially, but not in the cloud. So if I'm understanding, you're wanting a product like configurator, but not on the cloud. There is one. It is Inventor ETO. So that's not such a simple install. It's server-based. Okay, do we have any more questions coming in?
I think those were two separate questions there, Bob. One was about, are we going to have a webinar about how to make a product configurator with iLogic, which I think is something we may consider in the future.
We actually do have a product configurator. It's a configurator 360. There's a link inside. There's an add-in for 2016 that allows you to go up. It's all web-based, so you can upload your assembly and you can drive it with iLogic and parameters. So that might be something that we want to show, is configurator 360 at some point. Okay, that'll work. All right, and is there an effort to provide an A360 localized version? I'm not sure exactly what the question is specific. Do you guys have a different take on that? Don, Nate, Charlie?
My thought on that, Bob, would be that the potential person's asking a question may not want to drive the information on the cloud. If I'm understanding that correctly, probably
Okay.
looking not to drive it off of a cloud-based A360.
Okay. All right. We may have to address that separately. Nothing's coming to mind off the top of my head. And let's see, working with a client who has proprietary CNC software. If it depends on adding layers in AutoCAD, I want to work from Inventor and integrate with existing software. So it's regarding specific layers in AutoCAD and drive it. We do have CNC for Inventor, HMS, and I don't believe that it is controlled via specific layers. That would be a question you could send to cam.support@autodesk.com, and we will send you that link. Okay. All right, let's see. We have a question. Like to see any configurator and iLogic demos, as well as know if there is an alternative to having an in-house cloud or type of setup versus what Autodesk has. For Inventor, we have a product called Inventor ETO, and it's in-house. It can address your own personal cloud, and basically we can try to provide some information on that. If you just go look up Inventor ETO, that will provide you some information in regards to that. What we have for configurator in the cloud would be configurator 360, and we'll maybe see if we can't come up with some links to that when we send out everything, the webcast to everybody. All right, are there any other questions? Let's see. Going. All right. That looks like we have about it. Thank you all very much for attending. We will be sending you an email with the slide deck and a link to the webcast when it is published. Thank you all for attending. Have a good day.